Last time we chopped a smooth column into bins. Now we keep the column smooth but fix its shape when one long tail drags everything sideways. Picture total charges. Most customers are clustered low, but a handful of long tenured big spenders stretch way out to the right. That lopsidedness is skew, and a single number measures it. Positive means a long right tail. Why fix it? Some models, linear ones especially, behave best when inputs are roughly balanced. A few giant values can dominate distances and coefficients. So we squash the tail without throwing away order. Tool 1, log 1p. Take the log of 1 plus the value. No settings, no fitting, works whenever values are non-negative. It pulls the tail in hard, sometimes a little too hard, flipping a positive skew slightly negative. Tool 2, power transformer with Yo-Johnson. Instead of a fixed log, it learns the exact power that makes the column most symmetric, a single number called lambda. On our training totals, lambda lands around 0.26, and the skew drops from about 0.9 to nearly 0. Because lambda is learned, we fit it on train and reuse it on test. The wall again. Here's the whole thing in one file. We measure skew, try log 1p, then fit Yo-Johnson on train and transform tests. Load, coerce total charges to numeric, fill the 11 tenure 0 blanks with 0, split train and test stratified random state 42, measure the raw skew of total charges on train, about plus 0.9, a clear right tail. Apply log 1p, free, no fitting, and remeasure. It pulls the tail in, here a touch past symmetric. Fit power transformer Yo-Johnson on train. Transform train and test with the learned lambda. Train skew drops near 0, and the test skew comes out just as flat. Proof the train lambda transferred cleanly. Stage 3's number crunching is done. New features, ratios, bins, tamed skew. Next stage, we turn the categories into numbers, one hot, ordinal, and the target encoding leak. If this helped, like and subscribe for more.